Hi, this is a GMAT question from gmatquestions.org. For the function f of x equal 2x plus 2 to the power of 5 over 6, what are the values of x for which f of x is a real number? Okay, maybe you haven't seen this before, this type of function, but what makes it pretty, intimidating is the power here is a fraction, okay? So what we need to do here is before taking care of this function, I need to remind you of something important. So if you have x to the power, let's say p over n, this is the same as x to the power p, the n root of x to the power p. The numerator goes here inside with the x, and what is here, the denominator is really the root. So n root of x to the power p. Very important. Okay? For example, x to the power 1/2 is the square root, hold on here, the square root of x to the power 1. Now, there is a 2 here. We don't write it. When it's a square root, we don't write really the 2 root. We don't say a 2 root. We just say square root, but we don't write it. But if it was a cube root, we write the 3 here. Okay? And here we have a 1, so it's just root of x. And you may be already familiar with this. You may already be familiar with this, okay? X to the power 2/3 would be cube root of x squared. Okay? There's some algebra definition of the n root as it relates to a power that is a fraction. So if you don't know this, make sure you review this. This is important. Okay? And another thing we need to know also is that when you have root of, let's say, x to the power anything, let's call it maybe, p again. And we have n here. What we must know is that x to the power p has to be greater or equal to 0 if n is even. Okay? If n is even, for example, you have a square root, a fourth root, a sixth root, and so on, what is inside the radical here, what is inside, overall, has to be greater or equal to 0. It cannot be a negative number if n is even. Okay? N is even. For n odd, there is no such rule. If n is odd, you can have a negative inside. Okay? And not only that, the input, what is inside, has to be non-negative. Actually, when you have a square root, what happens, especially square root, what comes out has to be also non-negative, positive. And what I mean, if I can give you an example here, for example, the square root of 4, which is 2 square if you want. Okay, this is a square root. This is, you know that this is 2. It's not 2 and negative 2. It's just 2. And obviously, you cannot have, for example, the square root of negative 4. This is 2 square, which is 4. This is not allowed. Let me write it down. The square root of negative 4 is not allowed. Okay? Once again, if n is even, the n root of a certain entity is such that the entity that is inside the radical has to be positive, has to be non-negative rather. Okay? I hope I have made myself clear, because these are very important definitions here. And we're going to use this in order to solve this question. So let's write it down again. F of x equal 2x plus 2 power 5 over 6. So f of x has to be equal to the 6th root, 6 here because it's at the bottom, of 2x plus 2 to the power 5. Once again, because of what we established here on the right side. Since 6 is even, 2x plus 2 to the power 5 has, actually, instead of saying this, let's write down mathematically, must be greater or equal to 0. Absolutely. And that's what I was trying to explain here. Okay? If you had the 5 here and the 6 here, that rule wouldn't hold really, even though if you have a power 6, we are guaranteed it will not be non-negative. But anyway, understand this. 6 is even. This whole thing inside the radical has to be non-negative. Okay, so this is what we have to solve. Actually, this is called the domain. We are really looking for the domain of definition of the function. It's called the domain of definition. Okay, and that's what we're gonna solve in order to find the answer. So if solving this is pretty easy, actually. We can totally drop the 5. We can, and I have explained that before. When you have 0 on the right side, you know, all the numbers with an odd power gonna have the same sign. You know what I'm saying? Since 2x let me actually do it better, what I'm trying to explain here. Since x to the power 2k plus 1, 2k plus 1 is odd here. It means it's an odd power. Is as any other x to any other x raised to an odd power, you know, including x to the power 1, they really have the same sign. What I mean here, x to the power 2k plus 1, for example, x to the power 5, if x to the power 5 is negative, x to the power 1 will be negative. X to the power 3 will be negative. X to the power 100 or 1 going to be negative. If x to the power 5 is positive, x going to be positive. X to the power 101 going to be positive. That's what I mean by that. And the 0 here, you know, give us a chance to just do it that way. If you had 1 here, you cannot just do what I am about to do. Okay? So anyway, this equation can be solved by just saying that 2x plus 2 is greater or equal to 0. If you want, to the power 1, if you want. Okay? And this is going to lead us to easily x greater or equal to negative 1. Because if you, okay? I hope you have been able to follow me here. It's a little bit complex, but for some of you, I'm really spending time on it because some of you may have trouble going from here to here to x plus 2 to the power 1. Some of you understand this easily. It's no problem. But there are others, they don't know how I get from 2x plus 2 to the power 5 to 2x plus 2 to the power 1. That's because 2x plus 2 to the power 5 has the same sign as 2x plus 2 to the power 1. We have a 0 here, so this is positive. If this is non-negative, this has to be non-negative. Again, this is not the only way to do it. You could have done it actually a different way, by just breaking down this 5 into a 4 and a 1 and dropping the power 4. But this is a good explanation, just knowing that all the order powers have the same sign. Okay? If you don't know that. Great. So what is the answer? The answer is C. C is the correct answer. Great, right there. Thank you for watching. This is a GMAT question from gmatquestions.org.